Hi everyone. In today's video, I'm going to be going over the Quarter 2 Benchmark Review 2. This time I'm going to be covering the back side of the page. This covers Unit 3, which is over exponential and logarithmic functions. For this video, you will need some spare paper because you're going to have a hard time trying to fit all of the work and answers on this sheet, along with your TI-84 plus CE calculator or an equivalent graphing calculator. All right, before we jump into this, I want to do a quick review of exponentials and logs. Now, this is going to feel a little weird just because we're not going to do a lot of the stuff that I'm about to mention until we get to 22 and 23. The first two problems are just graphing, but I do want to go ahead and do a refresher first. So the biggest things you need to understand, first off, when you have a log, typically the base is specified, so this is log base of 7. When you see a log without a number written in that spot, I always have the hardest time coming up with random numbers off the top of my head. 8. If you have something like this where there's no number in its spot, then you understand, you're supposed to assume that this is a base of 10. So 10 is the assumed base of the log. If it's not specified to be a different number, it's 10. There's another type of log, and it is called the natural log, ln. It always has the same base, so it's never written. It's understood to be a base e. And e, remember, is a number, and it's like pi. So it's irrational. It doesn't repeat. It's a decimal. It does not repeat or end. And it's often kind of treated. You treat it in a similar way like pi. It's just kind of there. But what's nice is you can plug it into your calculator. Now, a lot of students don't prefer the natural log. They prefer to still use the regular log and write it with a base of e instead. It's x, not alpha. So these are equivalent forms, so you can use either one. I will let you know if you plan to study math at a higher level or science at a higher level, which would imply you do math at a higher level as well. Most professors, I honestly have never seen log base e of x before teaching here. It was always natural log of x. So professors, this is how they'll use it. If you're more comfortable with log base e of x, that might be something you want to discuss with them and see if they're okay with that. All right, switching between forms, exponential and logarithmic form, is one of the key ideas of the unit, and we use it a lot. We're asked often to switch between the forms logarithmic, and then there are many times we have to do this in order to solve an equation. So exponential is usually what I start with, and if we use plain letters, I call the base a, the exponent b, and it's equal to c. To change it to logarithmic form, you put a log where the base is at, and then you put the base, so you're going to kind of step down a little bit. This is a subscript, log base a, and then you're going to swap b and c's positions. So now C is going to be right here, and b will now be on the other side of the equal sign. There's a nice little expression we teach you to help you remember this. Base stays base, since the base stays the same. The other two, so other two, B and C, play switcheroo. So base stays base, the other two play switcheroo. So the base is A, it's the same in both forms, and then the two other numbers, B and C here, are going to flip places. So we go back and forth between the two. Just a quick reminder, the reason why this works, the switching, is because these functions are inverses of each other. That's why we're allowed to do this. That is something you do kind of want to remember, just something to keep in mind. All right, I feel like that's a good enough review for now. We're going to get some practice with that later. All right, so as I said, we're not going to start immediately with that. We're going to first do some graphing, then we're going to return to those concepts. All right, number 20. Y equals 3 to the x minus 2 plus 5. Our instructions. Describe the transformation of the parent graph, identify the asymptote, x and y intercept graph, and find the domain and range of the equation. So we have to find the transformation. The asymptote. X-intercept. Y-intercept. Domain and range. And I'm going to fit my graph into this little square over here. So, I'm going to go ahead and type this into my calculator. So, let me turn my brightness down real quick. Three to the parentheses x minus 2. I'm going to arrow down plus 5. All right, I can see that my asymptote is kind of high up. Sorry, I paused. I noticed I had changed my table a bit so that I had more decimals, and I didn't want that for this video. All right, I put it back to whole numbers. So as I can see, I get some pretty big numbers here, and then to get some nice points, I'm going to have to go up a little further than I'd usually like to. Let me see if I have any negatives to work with. Nah, the negatives aren't nice either. Okay, so ideally you're supposed to graph 3 points. So my 3 good candidates would be 2, 6, 3, 8, and 4, 14. So I do want to go up to 14. So what I'll do is like a shortcut. And since I'm not going to need the bottom half of the graph at all, I'm going to cut that down a bit. I'll make something that looks like this. So I have to go out to 4 on the x-axis, so that's not too bad. And then up to 14 on the y. So I'm going to do this in 5s. It'll make my life easier. Call that 5. Call that 10. We'll call that 15. Yeah. So, won't be the most accurate graph I've ever drawn, but you get the idea. All right, and then I need out to 4. So, I'm going to try and keep it pretty... I'm losing my train of thought completely. The same. Proportional. Proportional is what I look for. Okay, so my 3 points are 2, 6. So I'm going to graph that. Something like that. 2, 6. 3, 8. And then 4, 14. Yes. Okay, so something like that. And then, yeah. Wish I'd plot this a little bit higher now that I'm looking at it, but it's fine. It'll be fine. So as you can see on the graph, you can kind of see where the asymptote's going to come into play here. That's why this line is flattening out as much as it is. So I'll get to that in a moment. Let's talk about transformation. To do the transformation, you have to know what the parent graph looks like. I'll call that the PG. You look at your equation. This genuinely comes with experience and practice. I'm looking at this and I can tell the parent graph was y equals 3 to the x. The minus 2 here and the plus 5, these are changes made to this equation to change the graph in some way, shape, or form. So that parent graph is going to very easily help me identify what the transformations are. So we start with the x minus 2. Remember, when you have a movement with the x, a number with the x, that is a horizontal movement, left or right. Now remember, the x lies to you. It looks like one way, but it's actually the other way. You would read this typically as left 2, but it's actually not left 2, it's right 2. Right 2. And then the plus 5, this goes with the y since it's out here by itself. And this is a vertical movement up or down. And the good news is It's truthful. It's exactly as it looks like. So if it looks like a plus 5, that means it's up 5. So that was my transformation, right, 2 up 5. Asymptote. If you can't already tell where it's at on the graph of my calculator here, there's a very nice way to tell by this table. So if I go up, as you see, I'm going along that not quite horizontal line, but a flattening line. Notice once I get so far, these numbers all turn into 5s. I want to make it clear. None of these points actually are at 5 on the y-axis. What's happening, if you can't already see over here, I'm getting as close to 5 as I possibly can. Once I get to a small enough decimal, the calculator can't quite comprehend this, so it'll just put a 5 there. Again, these will never actually be 5. They'll be very close to 5, but not 5. So 5 here is our horizontal asymptote. And I always like to draw this in so that when I fill my graph, I don't touch it. So now I'm going to draw in the line itself. Being very careful not to touch it or cross it, any of that. All right, my asymptote, it's along 5. Now, a lot of students are still getting confused. Do I put x equals or y equals? This is cutting through the y-axis. So this is a y equals 5. X-intercept, pretty obvious that this is never going to touch the x-axis, so none. Y-intercept, can't see quite what that point is. Now we could get a pretty accurate number just by plugging in 0 for the x and solving. So let's do that. Y-intercept. X is 0. To think about it. So we plug in 0 for x. Y is 3 to the 0 minus 2 plus 5. That's 3 to the negative 2 plus 5, and then calculator for that. .1 repeating. So I'm just going to call that 5.11. And actually, I'm just not realizing, I think we could see this on the table. If I go to 0, yep, right there. So that actually wasn't necessary on this problem, but this is just a refresher as well. If you couldn't do it with the calculator, this is how you find it by hand. All right, domain. If we look at our graph here, this is all of the possible x values that are included in the graph. So if I'm looking, this goes infinitely to the left towards negative infinity. Follow through on the graph, it's a solid line. And then while it's going up, it's still moving to the right. So it's going to go infinitely to the right to positive infinity. So my domain is negative infinity to positive infinity. Range, however, is not the infinities. If I look at my graph, range, those are your y values. If I look at my y-axis here, I've got a lot of stuff down here that's left out. So I'm not going to start at negative infinity. This is going to start at positive infinity, where the asymptote is, and it will go up, or 5, and then it will go up to positive infinity. Infinity gets parenthesis. Here, technically, we are not starting exactly at 5 because the graph will never touch 5, but every number above 5. So 5 actually gets a parenthesis here. And there's my graph. All right, we're going to repeat that one more time for 21. Number 21. Y equals log base 2 of x minus 5 plus 4. Same information, we're trying to find the transformation. The asymptote, the x-intercept, the y-intercept, and then domain and range. graphing. To get a log function in your calculator, the buttons are math, alpha, math. Log base 2 of x minus 5 in parentheses, arrow out, plus 4, graph. All right, let me scroll down on my table to where I can actually see some points. So we are going to graph 6, 4, 7, 5, and 9, 6. So a much smaller range of values for this graph, so I don't have to draw it as big. Okay, so I need to go out to 10 on the x-axis. And then up to 6. Something like that. All right, my 3 points, 6, 4. 7, 5. And 9, 6. Right there. All right, I'm not going to draw my graph till I have my asymptote on the graph. Transformation. Again, this comes from knowing what the parent graph looks like, the PG. I'll write that in this quadrant since I won't be using it. So the parent graph, if we take out the transformations, we are left with log base 2 of x. Y equals that. Log base 2 of x. If we remove the plus 4 and the minus 5, that's our equation that we're left with. This is the parent graph. So if it helps having the parent graph in front of you so you can do a little comparison, then that's what I would do. So inside with the x here we got a minus 5. Again, you read this the opposite of what it looks like. So while it looks like a left 5, it's actually a right 5. And plus 4 you read exactly as it says. So this is up 4. All right, my asymptote. This one's going to be a vertical asymptote, and it looks different on the calculator from a horizontal asymptote, as you can clearly see by those error messages. If it's not obvious by looking at the graph, you can always look at the table. The first number that has that error message is where the asymptote is. So in this case, it is a 5. All of these numbers produce an error, but this is where the error starts. So that's your asymptote, 5. This one's going to be a vertical asymptote. That's what's causing this to kind of flatten out here just a little bit, or straighten out, I should say. I have a bit to say about that. I'll get to that in a moment. So 5. This time it's vertical. Unfortunately, the TI-84 is not the best at graphing log functions. While this looks like it comes and stops at a point right here, this function actually will keep going down forever. So I'm going to draw my graph that way. Let me extend it to the right. And then it's going to curve down and just keep going forever and ever. Again, this is one of those things where the TI-84 just does not comprehend this kind of concept for some reason. So it doesn't show it, but understand it is there. If you don't believe me, feel free to go on Desmos.com and graph this equation. It will show up on Desmos as it should. So that is very much there. And it's an important part of the graph to include. All right, our asymptote, vertical asymptote, goes through 5. And then again, to figure out which letter, this cuts through the x-axis. So this is an x equals 5. X-intercept, we definitely have one. It's kind of hard to see. So we can solve for it if you plug a 0 in for y and then solve for the x value. You would end up with your x-intercept. We're already going to kind of get a lot of practice in on graphing those. So, or not graphing those, but on solving these kinds of equations. So I don't really want to spend a lot of time on that today, but on this problem in particular. So we're going to say it's approximately 5, 0. It's obviously not going to be a nice number. It's going to be some decimal 4 point something because it can't actually be 5. But it's really close to 5, 0. And you would be able to see that if the graph showed that to you, which it does not. So we're going to kind of cheat here today. Y-intercept, this would clearly never come over here and touch the y-axis, so this is none. Domain, not the infinities this time. The left side of the graph here is not included. The domain starts at our asymptote, which is 5. And then when you follow it to the right, it points right. It's going to keep going infinitely to the right. 5 to infinity. And then since 5 is an asymptote, it can't actually touch 5, so that's going to get a parenthesis. Range, y values. As you can see, this is going infinitely down towards negative infinity, so that's where we will start. And then follow it up and through, it goes up towards positive infinity. So negative infinity to positive infinity. There's my graph. We are done with graphing for the rest of the video. Number 22. Now we're jumping into those problems I was discussing a bit earlier. So we have 2 to the 5th equals 32. All they want us to do is write the equation in its inverse form. So this is exponential, so we need to change it to a log. So the exponential part here, so I'm going to put a log in the front now. This base is still 2. Now I write it like a subscript. Log base 2. Remember the phrase, base stays base, the other two play switcheroo. So log base 2 of, it's now 32, equals 5. That's all you have to do. 23, same idea. Log base 3 of 27 equals 3. Now we change it to exponential, so find the base, it's 3. This is now the base of our exponent. And then we're going to switch these two. So now it's 3 cubed equals 27. And that's it. 24. This problem is so nice. This is literally testing your ability to use a calculator. This calculator. So again, math, alpha, math to get that to pop up. We'll do that one more time. Math, alpha, math. Log base 6 of 8. Round to 3 decimals. $1.161. 25. Here's where we're getting into some trickier problem types. We have to solve equations. Solve each equation, give exact answers and approximate answers where appropriate. That's typically kind of up to your own discretion. I wouldn't say that it's wrong to do one way or the other. So our equation is log base x of 64 equals 3. So I can't type this into my calculator, so I'm kind of at a standstill already if I keep it in the log form. This is why we talk about switching forms. This is where this is a very useful idea. We'll switch this over to an exponential form. I can work with it better if I have it in that form. So the base is x, so I'm going to rewrite this as x, and then its exponent, the other two play switcheroo, is 3, so x cubed equals 64. All right, so let's solve for x. Take the cube root of both sides. Those cancel. X equals the cube root of 64, which is 4. And that's it. If you're not sure if this is correct, remember, just like in Algebra 1 or 2, any algebra problem, you can just plug your answer back in and see if it works. So let's do that. And since I've already got a log in here, I'm going to just copy and paste it. log base 4 of 64, and then that should give me 3. And it does. Number 26. Log base 4 of x minus 1 equals log base 4 of 16. So we're going to use something called the one-to-one property. If you have one log on each side, you can drop them. Now this only works if you have one on each side. If you have a different number of logs on each side, that doesn't work. Even if you have the same number of logs, you had 2 on each side, that still wouldn't work. You'd have 1 on each side. That's why it's called one-to-one. So I can drop these. I'm left with x minus 1 equals 16. Add 1. X is 17. And this one's really easy to check. You can do this in your head. 17, plug it in here. 17 minus 1 is 16. And clearly that would match what I have on the right side. So that is the correct answer. All right, number 27. Eight to the x equals 10. Not super helpful right now. Again, it would be beneficial if I had the x on the right side by itself. If I switch the form, that's exactly what would happen because these two switch places. So let's change this into a log. Log, my base is still 8, of 10 now equals x. Plug that into your calculator to get your answer. Okay, I'm just going to copy paste. Log base 8 of 10. And this one I'll approximate for sure. Let's do 3 decimal places. 1.107. If you plug this back in, it will round to 10. Your final answer will, so it's a little off, but remember when you round a decimal, you're changing the answer essentially. So it makes sense that it's not going to come out as a perfect 10 if you use a rounded decimal and plug it in. But it is the correct answer. All right, number 28. Log base 4 of x plus 2 minus log base 4 of x minus 3 equals 2. Got a lot going on here. We have 2 logs on the left and none on the right. So we're not even going to be able to drop them, but we do need to condense this first, put them together. That's extremely important. If we just drop them now, 1, that's not allowed, and 2, remember, with logs, when you see a minus in between the two, this isn't actually subtraction, this is division. So if I just drop and continue solving from there, I'm changing the problem completely. So we need to condense this. This becomes log base 4, and then this is division, as I've already clarified, and the first term I have is going to go on top, and the second one's going to go on bottom. So x plus 2 over x minus 3 equals 2. So condense first and foremost. I definitely can't use my calculator for that, so let's switch the form because I'm kind of stuck. So change it to exponential form. The base of the log is now the base of the exponential, 4, and then the other 2 play switcheroo. So I'm switching the 2 with this fraction. We now have 4 squared equals x plus 2 over x minus 3. Let's simplify this. 4 squared is 16. All right, you can view solving this one of 2 ways. The first way is just by multiplying the denominator on both sides, or if you prefer, cross multiplying. If you have a fraction on one side and a regular number on the bottom, or on the other side, put it over 1 and cross multiply. It works every time. clarify, this only works when you have an equal sign involved as well. Just kind of a reminder there. So this gives me 16 times x minus 3 equals x plus 2. Now it's just your typical algebra equation. Distribute that 16. 16x minus 48 equals x plus 2. And then we're just going to solve for x. I'm going to subtract x over here to get 15x minus 48 equals 2. Add 48, we have 15x equals 50. Divide by 15. X is 50 over 15. And if we want to simplify, divide both of these by 5, we are left with 10/3. That is a repeating decimal, so this is definitely an instance where I am not going to turn this into a decimal. I will leave it. All right, that was number 28. 2 more equation problems to go. Number 29. Log of x squared minus 1 equals log of x plus 5. Okay, I have one log on each side and they are the same log, so I can comfortably drop this. So we have x squared minus 1 equals x plus 5. We have a quadratic here, so unfortunately, we're going to have to move everything to the left side, set it equals 0, and yes, factor or quadratic formula. So I'm going to subtract x and 5 on both sides. It's going to leave me x squared minus x, and then -1 minus 5 you can subtract. That becomes minus 6 equals 0. Reminder, x squared and x are not like terms, so I can't actually subtract them. I just write them down. This is actually a very easy one to factor. Factors of 6, the ones that immediately pop into my head, are 2 and 3. And we want a -1 out of this. So for this to be a -1, the bigger number 3 has to be negative as well. 2 minus 3 is -1. 2 times -3 is -6. I have found my factors. Don't forget we're solving for x, so we are not done. If we split these up and solve, x plus 2 equals 0. X minus 3 equals 0. X is -2, and x is positive 3. Now there is a rule for logs that you probably forgot by now that we do have to address. And getting negative answers are kind of a reminder of this. Logs do not like negatives, and they don't like 0. So if whatever number this turns out to be is a negative or 0, the log does not work. It gives you a domain error. It is not defined there. So what you need to do is you need to plug each answer in to both logs and make sure that whatever number comes out of it is still positive. So if I plug -2 into the left side, I would get -2 squared, which is positive 4, minus 1 is 3. So it's safe here. -2 plus 5 is still a positive 3, so -2 is a safe answer. And let's do the 3. 3 squared is 9, minus 1 is 8, that's positive. 3 plus 5 is 8, that's positive. So this equation has two answers, -2 and positive 3. Number 30. We have 6 plus 3e to the 2x equals 12. My biggest piece of advice for problems like this, you need to figure out what you are getting by itself. So this was always x, but that's not the case on this problem. We need to get this exponential piece by itself, and we don't want any numbers attached to it either. That's a no-no. So we just want this by itself. Subtract 6. 3e to the 2x equals 6. Divide by 3. E to the 2x is equal to 2. Again, we kind of get stuck at this point. We can't put that in the calculator, so let's switch forms. So we're going to take a log on both sides. A reminder, you can do natural log or log base e. They are both correct. I'm going to use log base e because I'm sure a lot of students prefer that form. Log base e, because my base is e, of, play switcheroo with the other two. This is 2 equals 2x. And then I'm going to fully solve for x before I type anything into my calculator. Divide by 2. X is log base e of 2 over 2. Quick note, these 2's do not cancel. Just type it into the calculator. So, alpha x to get a fraction. And then alpha math to get my log. Log base e is above the division sign in blue. So you have to hit second and then divide to get e. 2 in the parentheses and then 2 on bottom. And let's keep it to 3 decimals. 0.347. There you go. Number 30 is done. All right, expanding and condensing. Number 31. Log base 4 of 3 minus log base 4 of 4 minus log base 4 of 7. All right, condensing. First thing you want to look for when you're condensing is exponents. So exponents first. And we don't have any exponents. Remember, next exponents are written in front of the logs as numbers. So that's when you have an exponent. We don't have any of that going on. So no exponents here. Once you're done with the exponents, you go left to right and you do whatever is there. So if that is division, you divide. If that's multiplication, then you multiply. But you go left to right, so 2 terms at a time. So I'm going to start by condensing log base 4 of 3 and log base 4 of 4. Reminder, this minus here is not actually subtraction, it's division. So I'm going to write these as a singular log, base 4. And then this is a division problem. The first number is on top, the next number is on bottom. So this is 3/4. And then I'll bring down what's left. And I just repeat that. So I'm going to condense these two. Log base 4 again. From here, as you can see, this is going to be division again. Once you created a fraction, you're just adding to it. So if the next item is followed by subtraction, division, you're going to put whatever comes next on bottom. If I had a plus here for multiplication, I'd put it on top with the 3. So now I have 3 over 4 times 7. And then to finalize my answer, I have log base 4 of 3 over 28. To make it even more clear what's going on with the fraction, I'll put that in parentheses. There's my answer. All right, number 32. Log of 3xy all under a square root. Something you have to remember for this problem is how to write a square root as an exponent. Remember, it's as a fraction, and since this is a square root, it's just all of that to the 1/2 power. And then I would need to be able to split these up, so I'm going to distribute this 1/2 to all of these. Reminder, if these are all being multiplied together as they are, then you can just literally attach this to each number inside here, or variable. So this is log of 3 to the 1/2, x to the 1/2, y to the 1/2. Now I can go through and split these up. So when you are doing expanding problems, you start with division. multiplication, and then your exponents come last. So it's kind of backwards. It is backwards from what we do with condensing. So exponents come last instead of first. And then division and multiplication have a specific order, not just left to right here. So division, we don't have any of that, so we can ignore that first step here. Multiplication we do have. These are all being multiplied together. So I'm going to write this into 3 separate logs. So this is log of 3 to the 1/2, log of x to the 1/2, log of y to the 1/2, and then pluses for the multiplication. Because remember, we write them as addition when it's multiplication of logs. All right, multiplication is done. Now we can't leave these as exponents. We have to bring them all in front, like that. So this becomes 1/2 log of 3 plus 1/2 log of x plus 1/2 log of y. And that's it. So you're just going to take your time with these, step by step. Make sure you're not leaving anything behind. And if you didn't catch on the whole time, the base here was just 10, so that's why I didn't have a number written there. That is how you expand. All right, we have 4 problems left there, all word problems. Number 33. A certain strain of bacteria grows from 40 to 326 in 120 minutes. Find K for the growth formula. Y equals NE to the KT. This problem is not difficult. We give you the formula. You have to know what each letter here represents and how to solve it, which we've done several solving problems at this point. So our equation is Y equals NE to the KT. Let's talk about what each of these mean. Y is the new value. N is for initial value. That's what you start with. E is E. Leave it alone. I've got plenty of you dropping the E when you're doing this problem. You don't drop it. It's a number. It's there. But I'll specify E is E the number. And I'll specify don't touch it. You just bring it along for the ride. K is for constant. And T is time. And time just depends on the problem. So there's not a standard label here. So in our problem, we're told minutes. So our time for this problem is minutes. So how I showed you how to do this is write out each of your variables. Y and E is not a variable, so I will not include that. E is a number. To solve this, you can only have one unknown, but you do need to have an unknown. So I know 3 of these 4. So let's go back in and fill this in. A certain strain of bacteria grows from 40 to 326. So we started with 40 and ended at 326. Started, the initial is 40. N is 40. Y is the new value, 326. And then it says that's in 120 minutes. So T is 120. On top of that, the problem explicitly says to find K. So we know K is what we're missing. So let's plug it in and solve. Y is 326 equals N is 40. E to the K is still unknown times 120. Solve for K. So reminder, the goal is to get the exponential piece by itself. So first we divide off the 40 on both sides. And I believe that's a nice decimal. 326 divided by 40. Yep. 8.15 equals E to the 120K. Now we're kind of at a standstill because I can't put that in my calculator. So let's switch forms. So This is an exponential form. I want it in log form. This will become regular log or natural log. Base is still e. Base stays base, so you have the 2-place switcheroo of 8.15, and then the 120k will go over here. To keep this as streamlined as possible and to round at the very last minute, I'm going to solve for k and then use my calculator. So divide by 120. K is log base e of 8.15 over 120. So I'm going to type all of that into my calculator. So I need a fraction. This is where using natural log is slightly quicker because you write natural log instead of log base e. There we go. Log base e of 8.15 over 120. Just to show you it works either way, I'm going to do it a second time with just the natural log. Yep. Same answer. All right. And I don't believe we were told how to round. No. So I'm going to stick with 3 decimals, 0.017. And that's it. And k is a constant, so it doesn't get a label. All right, 3 more problems. And I'm going to switch to another piece of paper for this one. Here we have our angle of elevation depression problems. Pay extra close attention here. We've got 3 of these. Number 34. A 20-foot ladder is leaning against a house with an angle of elevation of 62 degrees. How far up the house does the ladder reach? So my best advice I can give you is to draw the picture. I'm going to get very exaggerated here, but it's just to drive home the point. The better you can visualize this, the easier the problem seems. So we have a ladder leaning against a house. Let's start there. So I've got my house. Then I have a ladder leaning against said house. Hopefully you can already see the triangle forming. And then I'm going to backtrack. It says it is a 20-foot ladder. So the ladder is 20 feet. So that's 20. And then we have an angle of elevation of 62 degrees. I'm going to back up here. This just comes from pure experience. Angle of elevation, when you have your typical triangle, it's at the bottom here, which is where it's drawn. So you can see our triangle. This is our hypotenuse. This is our right angle. House is the vertical. So there's my triangle. So the angle of elevation is going to be down here on the bottom. And I always talk about the neutral line when I teach this in geometry. You have a straight line and then you have the angle up. That's what is going on here. So that's how I know that's where my angle of elevation is. It's going up. It is 62 degrees. That's given to us in the problem. Make sure you read this carefully. If they're giving you a value that is in degrees, it better be put in an angle spot and not on the side of a triangle. By the way, we'll never put an angle right up here in this part of the triangle. Not with this kind of drawing, at least. Okay, so you need to have 3 pieces of information. You need to have 2 sides and an angle. We have an angle and a side, so we need to figure out which side we are trying to solve for. So the question, how far up the house does the ladder reach? Don't overcomplicate this. How far up the house does the ladder reach? So they're asking what this measurement is here. The height of the triangle. So I'm going to put an X there. That's what we're solving for. Okay. Step 1 is drawing the picture correctly, and that's an important one. If you don't draw the picture correctly, then your problem's botched from there. All right, so we need to label our sides. 20 is our H, our hypotenuse, and then O, opposite our angle here is the x. A is what's left. One of the biggest questions I get is how do I know which function I use? Because reminder, from here we use trig. I do not want to see a single person solving this with Pythagorean theorem. Pythagorean theorem is used for 3 sides of a triangle. We can't even do that because we have one side of a triangle. If we did have 2 of the 3, all we would be doing was finding the third side. That's not what we're looking for. And on top of that, you cannot plug 62 in here. It's an angle, not a side. So do not use Pythagorean theorem here. This is a trig problem. This is why we teach you trig. So here are your options. Sine of theta equals O over H. Cosine of theta equals A over H. And tangent of theta is O over A. 3 options. Only one of these is correct because we have the information for this one in equation. Sine. We have O and H. We do not have A. So it can't be cosine or tangent in this problem. So we are going to use sine here. So my equation, sine of theta equals O over H. We have to fill in theta, O, and H. If you're not quite sure, start with the O and the H. Those are pretty obvious. But reminder, theta is an angle. So your angle will always go there. My angle is 62. Sine of 62 equals O is x over H is 20. When your x is on this side, it's in the fraction. You can always solve with cross multiplication. Put this over 1 and cross multiply. Yeah. X times 1, that's just x. Sine of 62 times 20. So I'm going to write it as 20 times sine of 62. Calculator. I'm going to get an answer right away. 20 sine of 62. You can squish them together like this. The calculator does read this as multiplication. And let's still do 3 decimal places. 17.659. And I believe it's in feet because the ladder was in feet. So feet. All right, 2 more. 35. A 20-foot ladder, a 32-foot tree casts a 21-foot shadow. What is the angle of elevation of the sun? So, we have a tree. It casts a shadow on the ground, as most items do on a sunny day. We have our sun somewhere over here, causing the shadow. What is the angle of elevation of the sun? Hopefully you can already see the triangle forming, visually speaking. If not, we have a 21-foot shadow. We know this is 21 feet long. So this is 21. And then we are given the tree height. The tree height is 32 feet. So this height here is 32. So vertical, horizontal, my hypotenuse is drawn like this. Kind of ruining my drawing here, but it's okay. So 21, 32, angle of elevation. Remember, it's at the bottom down here. So, and this is our straight line, so up, angle of elevation, up towards the sun. We don't know this. What is the angle of elevation? That's the question. So we're going to leave this as theta. Or if you want to write it as an x, that's fine too. But I'm going to write it as theta. 3 pieces of information, an angle and 2 sides. We have what we need to start. To figure out which trig equation, you have to figure out which sides of the triangle you have, of the HOA. Hypotenuse H is across from the 90. O is opposite the angle. A is what's left. Clearly we are not using H. It is blank. O and A it is, tangent. So, yeah, I have enough space. Tangent of theta is O over A. Tangent of our angle, which theta, we don't know it, so it's theta, equals O is 32 over A is 21. Okay, how we solve this. This is kind of an introduction into using inverses to solve equations. This is something you're going to get very comfortable with next semester, so it's good to start practicing it now. We have to get the theta by itself. That's what we're solving for. So we have to remove tangent from theta. This is not done by division because this is not a multiplication. Reminder, I say tangent of theta. This is a function of theta. So there's a special way to remove it, and that's with tangent's inverse. That's the tangent with the -1. So here's how we do it. We apply it to both sides of the equation. With practice, this will become seamless for you. So, I'm doing this to both sides, so I'm going to put these inside of these parentheses. Tangent of theta, and then 32 over 21. Now, because tangent and inverse tangent are literally inverses, this is going to cancel. Sorry, this is theta. So now I'm left with just theta over here, equals inverse tangent of 32 over 21. And then I just got to use my calculator to figure out what it is. Theta is approximately, let's figure that out, inverse tangent of 32 over 21. So if we just did degrees, I would round this to 57 degrees. Depending on the problem, you'll want to pay attention. They might ask for degrees, minutes, seconds. So you could transfer, or I don't want to say translate, words. Change this into degrees, minutes, seconds. If I were to do that, it would be 56 degrees. And then we do have just enough seconds to bump this up to 44 minutes. So, depends on your problem. You're going to want to pay extra careful attention to that. And that's our answer. By the way, this isn't new. Remember, when we are doing these problems on a coordinate plane, and we're trying to find that alpha inside the triangle, remember we do the inverse of one of our functions that we find. It's the positive one. That's how we find alpha. That's exactly what we're doing here. It's that exact same process. That's what we're finding. That's why this works so well. So hopefully you recognize that now. Okay, we have one problem left? Yes. And these are the angle of depression problems. Again, get fun with your drawing. Johnny is standing at the top of a 324-foot building. The angle of depression to a car on the street is 53 degrees. Find the distance from the car to the base of the building. So, again, I'm going to get detailed here. Detailed enough. Drawing cars is not my strong suit for sure. So we have a building that is 324 feet tall. And then we have Johnny up on top of this building. And then we have an angle of depression. I'm going to draw that in a moment. To a car on the street. So I have a car somewhere over here. Forgive me. That's slightly better than what I drew earlier. Yeah, that's as good as it's going to get. Okay. So when I teach this, especially if you are not in my class and you're watching this video, I just want to give you a little heads up. Here's how I teach angle of elevation and depression. I teach it as a line of sight thing. So if you think of a person's eyes, before you can establish if they're looking up or down, you have to establish what is not up or down, what's in the middle. So looking straight ahead. I call that neutral. Because then if I look up from here, it's an angle of elevation. So if I look up, that would be elevation. And then if I look down, that would be depression. So what I'm getting at here, a lot of teachers teach angle of elevation or depression, that you draw this, you reflect your triangle over itself, and then it looks like a normal triangle. I don't even do that. You're already drawing an upside down triangle in the process, so I use that upside down triangle in my diagram. So that's what you're going to see in a moment. So before you draw your person looking down, draw them looking straight ahead. That helps you draw it correctly. Draw it up straight. Now he's looking down, creating that angle of depression towards the car. So I'm going to take this away. So the angle of depression to a car on the street is 53 degrees. So this is an angle going down at 53 degrees. And as you can see, I practically have a triangle here. Let's finish it. Right angle. Now one detail I kind of misplaced is my vertical. Not that I misplaced it, but I need to move it into my triangle. The vertical is 324 over here, so I'm going to put the 324 here. All right, we have two of our three pieces of information. We have our side and our angle. We need one more side. Find the distance from the car to the base of the building. Again, having a nice picture makes this less complicated. Find the distance from the car to the base. Base means bottom of the building. Car, building. Horizontal distance is what we're finding. So this distance here, which is also this distance up here. So this is my x, the horizontal line. We are not going to be finding the hypotenuse. The hypotenuse is the distance from Johnny's face to this car. That was not asked for. Here's our drawing. Now we need to figure out which function we're using. Again, label your HOA. H for hypotenuse, O is opposite the angle, A is what's left. Again, we have O and A, so we are going to use tangent. So my equation, tangent of theta equals O over A. I always write out the general form and then I plug in my stuff. Tangent of 53. 53 is the angle of depression, equals O, 324 over A, which is x. Now I solve. Again, if x is on the right side in the fraction, you can just put the left over 1, create two fractions, and cross multiply. The only time this doesn't work is when x is actually theta and you're trying to find it. This gives me 324 equals x times, because we are multiplying, tangent of 53. So to solve for x, I need to move the tangent off of it. This is multiplication, so to do that, I will divide by tangent of 53 on both sides. Guess we want to be completely correct here. These will cancel. And then whatever this is, that's my x value. So let's plug it into the calculator. 324, 24 over tangent of 53. 244, 3 decimals, 0.152. I should have mentioned this much earlier in the video, but these are trig problems, so make sure your calculator is still in degrees. If you're getting different numbers and typing in the same thing, that's might be why it's not working. All right, that was our last problem. Hang on, let me add my label. Is it feet? Yes, feet. We're not going to be sticklers on that. I just like to be completely correct here. All right, that is all for this video. I hope that this was helpful. Pay extra close attention to these angle of elevation depression problems. I know across the board in all of our classes, that was a huge issue. having learned it in geometry but only spent a couple weeks on it, I can understand why it was a bit of a shock. So make sure you take your extra time to study it. And again, never underestimate the power of a really good picture, or even just a silly one, to get your point across. Like I said, I hope this helped. If you have any questions, feel free to reach out to me or your teacher, or come talk to us in person. Otherwise, I hope you have a wonderful day. Bye!